Hello and welcome back to Chopstick Maths. In this video, we shall find the solution to this given differential equation, which is sum number 5 from exercise 4. The given differential equation is 2x square y plus e raised to x into y dx minus into bracket e raised to x plus y cube dy is equal to 0. So now we can rewrite this given differential equation by multiplying both the terms inside the bracket with y. So this would be 2x square y square plus y into e raised to x dx, and here we can take the positive sign outside the bracket. So both the terms inside the brackets will change their sign. So this would be plus into bracket minus e raised to x minus y cube dy is equal to 0. Let us call this as equation 1. Now we will have to first find out if this given differential equation is an exact differential equation or not. So let us compare this differential equation with m dx plus n dy is equal to 0. And on comparing, we get m is equal to 2x square y square plus y into e raised to x, and n is equal to minus e raised to x minus y cube. We will have to now differentiate m partially with respect to y and then differentiate n partially with respect to x. And if the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x, then we can say that the given differential equation is an exact differential equation. So let us now proceed to find the partial derivative of m with respect to y and partial derivative of n with respect to x. Now m is equal to 2x square y square plus y into e raised to x. Therefore, del m by del y is equal to 2x square del by del y of y square. Now whenever you are differentiating partially with respect to y, we have to treat x as a constant. 2 is a constant and we will have to treat x square as a constant. Hence, we will have to write 2x square outside. So this would be 2x square del by del y of y square plus. Now again in this term, we will have to treat e raised to x as a constant. So we will have to write e raised to x outside. So this would be plus e raised to x del by del y of y. Now del by del y of y square is 2y, so this would be 2x square into 2y plus del by del y of y is 1, so this would be plus e raised to x into 1. Hence del m by del y will be equal to 4x square y plus e raised to x. Now n is equal to minus e raised to x minus y cube. And now we will have to partially differentiate, we will have to differentiate n partially with respect to x. Therefore, del n by del x will be equal to minus del by del x of e raised to x minus del by del x of y cube. Now, del by del x of e raised to x is e raised to x. So this will be equal to minus e raised to x, and whenever we are differentiating partially with respect to x, we will have to treat y as a constant. Hence, del by del x of y cube will be equal to 0. Therefore, del n by del x will be equal to minus e raised to x minus 0. Hence, del n by del x is equal to minus e raised to x. Now we can see that del m by del y is not equal to del n by del x. Hence, the given differential equation is not an exact differential equation. We will have to now find a suitable integrating factor such that when we multiply this given differential equation with the integrating factor, this given differential equation will reduce to an exact differential equation. If del n by del x minus del m by del y upon m is a function of y only, say f of y, then the integrating factor is equal to e raised to integral f of y dy. Now, del n by del x minus del m by del y upon m is equal to minus e raised to x minus into bracket 4x square y plus e raised to x upon m is equal to 2x square y square plus y into e raised to x. And this will be equal to minus e raised to x. Now since there is a negative sign outside the bracket, both the terms inside the bracket will change their sign as we open the bracket. So this would be minus 4x square y minus e raised to x upon 2x square y square plus y into e raised to x. Now this would be minus 4x square y and minus e raised to x, and minus e raised to x is equal to minus 2 into e raised to x upon 2x square y square plus y into e raised to x. Now here in the numerator we can pull out the negative 2 common outside. So this would be minus 2 into bracket 2x square y plus e raised to x upon, in the denominator we can pull the y common. So this would be y into bracket 2x square y plus e raised to x. Now the term 2x square y plus e raised to x will cancel out each other in the numerator and the denominator. And what will be left is minus 2 by y. Hence, del n by del x minus del m by del y upon m is equal to minus 2 by y, which is a function of y only, say f of y. Hence, the integrating factor is equal to e raised to integral f of y dy. Now, let us substitute the value of f of y in the integral, which is equal to minus 2 by y. So, the integrating factor would be equal to e raised to minus integral 2 by y dy. Now, we can pull out the 2 outside the integral as 2 is a constant. Now, this would be e raised to minus 2 integral 1 upon y dy. Now, integral of 1 upon y dy is equal to log of y to the base e. Hence, the integrating factor will be equal to e raised to minus 2 log of y to the base e. Now, we can simplify this integrating factor by using the property of log, which is m log a to the base e is equal to log a raised to m to the base e. Now, we can write the integrating factor e raised to minus 2 log y to the base e as e raised to log y raised to minus 2 to the base e. Now, we can further simplify this by using the second property of log, which says e raised to log f of x to the base e is equal to f of x. Hence, we can now write this integrating factor e raised to log y raised to minus 2 to the base e as y raised to minus 2, which is equal to 1 upon y square. Hence, the integrating factor is equal to 1 upon y square. Now, multiplying the given differential equation, that is equation 1, by the integrating factor 1 upon y square, we get 1 upon y square into bracket 2x square y square plus y into e raised to x dx plus 1 upon y square into bracket minus e raised to x minus y cube dy is equal to 0. So, this would be 2x square y square upon y square plus y into e raised to x upon y square dx plus minus e raised to x upon y square minus y cube upon y square dy is equal to 0. Now, the y square in the numerator and denominator cancels out each other. So, we get 2x square plus, here the y would cancel out each other in the numerator and the denominator. So, we would get plus e raised to x upon y dx plus, now in this term there is no common factor to cancel out. So, we will have to write this term as it is. So, this would be plus into bracket minus e raised to x upon y square minus, now over here y square would cancel out each other in the numerator and denominator. So, we would be left with minus y dy is equal to 0. Let us call this as equation number 4. Now equation number 4 is obtained by multiplying the given differential equation by the integrating factor 1 upon y square. Hence, equation 4 is an exact differential equation. And its solution would be integral m dx treating y as a constant plus integral n dy integrating only those terms which are free of x is equal to some constant c. Now we have to integrate m with respect to x and treating y as a constant. Therefore, this would be 2 integral x square dx plus, now the second term has a y in the denominator. So we'll have to treat y as a constant. So we'll have to write 1 upon y outside the integral sign. So this would be plus 1 upon y integral of e raised to x dx plus, now we'll have to integrate n with respect to y and we'll have to integrate only those terms in n which are free of x. Now n is equal to minus e raised to x upon y square minus y. Now the first term in n has e raised to x in the numerator, so we'll have to neglect this term. The second term in n is minus y and this term is free of x, so we'll have to integrate this. So this would be plus integral minus y dy is equal to some constant c dash. Now we can rewrite this as 2 integral x square dx plus 1 upon y integral e raised to x dx. We can pull the minus sign outside the integral. Minus integral y dy is equal to c dash. Now integral x square dx is equal to x cube by 3. By using the formula integral x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. So this would be 2x cube by 3 plus integral e raised to x dx is equal to e raised to x. So this would be plus e raised to x upon y and integral y dy is equal to y square by 2 again by using this formula. So this would be minus y square by 2 is equal to c dash. Now taking the LCM, we can write this as 4x cube y upon 6y plus 6 e raised to x upon 6y minus 3y cube upon 6y is equal to c dash. Now rewriting this with a common denominator 6y, this would be 4x cube y plus 6 into e raised to x minus 3y cube upon 6y is equal to c dash. And this would be 4x cube y plus 6 into e raised to x minus 3y cube is equal to 6 c dash y. Now let us write this constant 6 c dash with a new constant c. So this would be 4x cube y plus 6 into e raised to x minus 3y cube is equal to cy. And this is the solution to the given differential equation. Thank you very much for watching the video. See you in the next video. Until then, bye.